Here's one more from page 56 of your book, Separable Differential Equations. This is problem number 19. Parentheses 1 minus x times dy equals x parentheses y plus 1 dx, and the initial condition y at 0 equals to 0. So this means we're going to get a particular solution for this problem. And you know, the last two problems we did had a constant in there, a c. And in this case we can figure out what c is because we're given an initial condition, a starting condition. Alright, and so let's go to it. We're going to separate x's from y, so I'm going to divide by y plus 1 and divide by 1 minus x. It gives me dy over y plus 1 equals to x over 1 minus x dx. And so again, one more time, we've separated x's from y's, dy's from dx's, and now I can integrate because I have a differential in each term. Now it's important that your differentials are numerators, not in the denominator. If you try to integrate with a differential in a denominator, you're just going to get junk. Alright, so now this is a dy over y form. It's a logarithm form. And in fact, it's going to be the natural log of y plus 1. Absolute value. And then the right side, well, let's do a u substitution this time. We did one very similar in the last problem, I believe. But let me try the u substitution method here. So if I let u equal to 1 minus x, du is negative dx. Can't forget my negative here. But in substituting, we also have to substitute for x. And if I solve for x, x will be 1 minus u. So this becomes the integral of 1 minus u over u minus du, because dx, the negative, will be a negative du. And if I multiply the minus 1 through here, we'll end up with the integral of u minus 1 over u du. So the negative distributes, it basically reverses the 1 minus u. Now, so I've got natural log, absolute value, y plus 1 is equal to, and let's divide u into both parts here. I've got 1 minus 1 over u du. So when we integrate this, we'll get a u minus a natural log of u. U minus natural log u. And then plus our ubiquitous constant, c. Alright, now let's get the x's back in it. So I've got natural log, absolute value, y plus 1 is equal to, u is 1 minus x, minus natural log, the absolute value 1 minus x, plus a constant. Now here's something neat we can do. The constant's a constant. 1 plus a constant is still a constant. So this 1 gets absorbed into that constant. I can get by with just wiping it off. It's still a constant. So that's kind of a neat thing we can do. Alright, well, let me make some room here. At this point, I'm inclined to go ahead and put in the initial conditions. And because this will, the initial conditions allow you to figure out what that constant is, what that c is. So when I plug it in, you know, when x equals 0, y equals 0. So this will be natural log of 0 plus 1. Natural log of 1 is equal to minus 0 minus natural log, x is 0, natural log of 1, plus a constant. And what's the natural log of 1? It's 0. 0, 0, c. c equals to 0. So our additive constant ended up being 0, which means my answer, tentatively, is natural log, absolute value of y plus 1 equals minus x minus natural log absolute value 1 minus x. C was 0, so I can ignore that. Now I'm going to get rid of that logarithm. If I add this to the left side to cancel it, I'll be adding logarithms. And the addition of logarithms is the logarithm of a product. So it becomes natural log y plus 1 times 1 minus x equals to negative x. So I combine steps here. This is a log plus a log. That means it's the log of a product. And now I'm going to get rid of the logarithm, the natural log, make both sides an exponent of e. That essentially cancels this. So I end up with y plus 1 times 1 minus x equals to e to the minus x. So there you go. Let me see if that's how the book wrote it. And let's see. Actually, that's exactly how the book wrote it. So it's kind of rare to get your answer to work out to look exactly like the book. So there we go. That's separable differential equations, and I think you'll see that it's really they're an exercise in algebra and integration. And so we haven't done anything that's really outside the scope of a calculus course yet. The next topic we get into will take problems that are not separable, and by doing a certain transformation will make them separable. Those are so anyway, that's all for this topic.